Sir, this is the first lecture of week 2 live session.
Sorry, I don't know why session is. No, Sumit, it is not a first live session. The first one we have taken yesterday. Yeah. So basically, what is the meaning of the trans impedance amplifier? Like we have two particular things. If you go through with the internal circuit of the operation amplifier, so like this is we have this circuit. Okay. One thing is that resistor. Now, if it is a V1, it is a V2. Here internally, if we say this is my circuit. Okay. What is the this particularly if it is behave as a voltage source plus and minus, minus connected with the ground, positive connected with the output terminal. Okay. Now the voltage drop across this resistor, there are two things that one particularly is the V1 minus V2. So we are taking that A of V1 minus V2 is the voltage source. Okay, that is the voltage of voltage source. Okay, if I say this is a V,
Yes, sir.
Okay, sir.
okay. Now the thing is that if my voltage output voltage is dependent on the input voltage, we say that this is the because the value of A is if I calculate the value A is Vx upon V1 minus V2. So this is the ratio of voltage gain. Okay, so that's why it is called the voltage gain A. Now second thing is that if I use this was in a way like I have V1, V2, the current is flowing is the I1. Okay, now we have this particularly, sorry, mm, the voltage drop is V1 minus V1 and V2. So the voltage drop across this resistor is V1 minus V2. Now we take this particularly as a current source. Okay, so this current source I am taking as a G of V1 minus V2. Okay, and their value is equal to the value of current source. Now if I calculate the value of G, so G is nothing but I upon V1 minus V2. What is called V upon I is impedance, okay,
Yes, sir.
and I upon V is conductance. So basically the this G multiplication is called the conductance, okay, or this type of configuration is called the transconductance configuration. Okay, that's why the operation amplifier is mainly used as a VCCS, voltage controlled current source. Okay, so this is the V1 minus V2, that is a voltage. On the basis of this voltage, it behave as a current source. So it is called the voltage controlled current
Excuse me,
source.
sir.
Yeah.
Sir, in the lecture, professor,
Mhm.
like every time he used the operational amplifier as a voltage source. So
V
what I assume
V
from the lectures, yeah.
yeah, VCVS and VCCS, both scenario we are using. Okay, operation
So, but
amplifier.
in the second
But
case, you are using operational amplifier as a current source, right?
yeah, as a current source. Okay, the
Sir, is it
configuration, if
even
you
possible to use operational amplifier as a current source?
if we are using, like for example, if you go through with the lectures,
Okay.
there is one phenomena is that we are apply the current source.
So, like even when while describing this trans impedance amplifier, he took that example that we need to produce that IR voltage, and he said
Mm-hmm.
that just use a current source and in series take a resistor, and
Mm-hmm.
then at the node of the resistor you will get IR voltage. You can
Mm-hmm.
compare that IR voltage with the variable voltage source and
Mm-hmm.
adjust the knob so that the voltage becomes equals to the IR voltage.
Mm-hmm.
So,
Okay.
like in that case, also there is a variable voltage source, right?
Mm-hmm. Yeah, that is okay.
But in your, yeah,
So basically, we use operation amplifier. There is a different type of operation amplifier as available. Either they are working in the VCVS or they are using as a VCCS. Okay,
okay. So,
so
like
both
it can be
we
used
are
as a
taking
voltage source or current source.
different type of VCVS, a different type of operation amplifier. Not a single operation amplifier will be work on the both scenario. Okay,
Okay.
like
So,
there
like,
are
sir,
the hmm,
this also means that the output impedance and the input impedance of the operational amplifier will depend on the configuration, whether it is a voltage source or it is a current source.
yeah, exactly.
Okay.
Exactly. If we take, but generally we are taking that VCVS. Okay, but VCCS operation amplifier is also available.
Got it, sir.
Okay. Yeah. Any other things? Any other doubts? No doubts. So I think in the last class, what we cover, the last topic I think remaining. Yes.
Yes, sir.
Okay. Uh, so we go with the multi-stage amplifier. I think we go this circuit. If you remember, mm, I think we go with this circuit. Okay.
Yes, sir. Yes,
Check
sir.
that this one is a positive, negative, again positive, negative. Here the voltage we are getting, if it is a R1, R2, R3 and R4. So here we are getting the V out is VI 1 plus R2 by R1. Okay. This is the V out. If we say this is the Vx, so in terms of Vx, Vout is equal to Vx into 1 plus R4 by R3. So the Vx is equal to Vout, sorry, Vx is equal to Vout upon 1 plus R4 by R3. Okay, and the Vout is this one, so Vx is equal to Vi 1 plus R2 by R1 upon 1 plus R4 by R3. Okay, we have already calculated this one. Any doubt in this one?
No, sir.
Okay. Now we go through with one more circuit. Mm, okay. So there are two particular resistance are though particularly feedback are there. Feedback from this one and feedback from this one. So both feedbacks are coming here. Okay. Now we have to check what is the terminal we are using here. So I am taking this one. Okay. Increase the voltage. So we are getting a voltage smaller here. Okay, so this terminal we are getting a smaller voltage. Why? Because some voltage will be drop across RF and the remaining voltage will be appear here. Now if become it is a positive, it is a negative, we are consider both case, multiply with way. So if it is a positive, increase positive, if it is a negative, negative, multiply with a, so become positive and become negative. Okay, both scenario. Now similarly case will be appear for the bottom side also. Okay, if we increase the voltage will be here, the little some amount of the voltage is there. Now when the voltage will be here, so it become positive or negative, so it become positive, positive voltage become negative, negative voltage, multiply with a, become positive in the positive direction a and negative direction a. Okay, so both condition will be possible. Now the thing is that where we are getting a more negative voltage, so we are consider that one with the as a negative bias, negative particularly. Clear? So for this one, the thing is that we have to identify RF, R2, R1. If we know the value of RF, R1, R2, R1 and R, we can identify that where the voltage drop is the maximum, so where the effect of negative terminal is more as compared to other terminal. Okay, so this configuration where we consider that either it become positive or it become positive, like for example this is the R, this one is the R and this one is the R, all resistance are equal. Now either you consider this one is a positive or negative, no issue, either you consider this one is a negative and positive, no issue. Okay, problem where the problem will be arises when the value of R will be different. Okay, any doubt?
No, sir.
Yeah, so now if I consider some values, so we can better identify that which is behave as a negative and which behave as a positive term. So like for example, I am taking this R, 2R, 3R, 2R. Okay. Now consider the effect. Can you identify? Like if I increase the voltage. Yeah. Okay. So what is the voltage at this point?
Sir, I think it will increase.
It will increase. Okay. So I just consider that what is the voltage drop here? So some voltage will be
Sir,
drop
where?
here. Okay. Some voltage will
Yeah.
be drop here. So if I identify that what is the voltage drop here, I can calculate what is the voltage here. So like I just change that del V voltage will be changes. Okay. The voltage will be increases del V. So we are getting at this point is del V 1 by 3. Why? Because we apply the voltage divider biasing. Okay. So
Yes, sir.
the voltage del V voltage. So basically this circuit is like that one. Del V, there is 2R resistance, then R resistance, then V in. If I consider mm, that this is behave as a ground, we can easily identify the value. This behave as a ground. So if I am consider this is a ground, so the voltage drop at this point is del V into R upon R plus 2R. So that is del V upon 3. Okay, so del V 1 by 3 we are taking. Yes. Now, if this is the voltage drop, so what is the voltage drop at this point? Again, this is the del V variations. It will be passing from 3R and 2R. So what is the drop at this point is del V into 2R upon 2 plus 3R. So 2 del V by 5. So at this point 2 del V by 5. The which value is higher? This is 0.33 del V. This is 0.4. Okay, 2 by 5. 0.4 of del V. Okay. Now if I minus this one, so the value will be higher. The value will be the negative. This particularly case multiply with a, so the value is more lower. But if I use minus sign here, so the value because of this particularly terminal will be more negative as compared to this one. Clear? So if we know the voltage at these 2 points, if we know the voltage at these 2 points, like one point is this one and one point is this one, which particularly value is higher? Okay, if I multiply with the negative sign, so that particularly value will be more negative. So this particularly value is more negative. So we consider this is a negative, this is a positive sign for a more reverse bias. Okay, so that's why the circuit behave as a negative feedback. Okay, any doubt? Similarly, I think professor used that particularly terminals, that is a 10R, that is R, sorry, R and 2R. So we calculate the voltage. So I just consider that this is the V1 voltage. So what is the value of V1? Yes, what is the value of V1?
Ten by 11 V out. V out.
10 by 11 V out. 10 by 11. Yes,
1 by
10 by
11.
11. 1 by 11 because we have particularly this resistance. Del
Okay.
V,
Yeah.
del V, 10R and R. So what is the voltage drop at this point is the voltage between these two. Okay, so del V R upon R plus 10R. So it is del V by 11. Okay, so V1 is del V by 11. Now what is the voltage drop at this point? V2, I consider this one as a V2. Del V R to R. Yes, what is the voltage drop?
2 by 3.
2R by
Yeah, 2 R
R
by.
plus 2R into del V. That is 2 by 3 of del V. So V2 voltage is 2 by 3 of del V. Which voltage is higher? V2 is around 0.66 del V and V1 is around 0.09 del V. So this voltage is higher, so I just use minus sign here and plus sign here. Okay. So which particularly voltage terminal voltage is, because if I consider V1 minus V2, so what is the value? The value will be negative. V1 is connected with positive, V2 is connected with negative. So V1 minus V2 is negative voltage. Negative. If I use the V2 minus V1, so what is the meaning of that one? V2 will become positive, the particular terminal will become positive, that terminal is negative. And V2 minus V1 become positive. If V2 minus V1 become positive, multiply with the amplifier gain, so that particularly value is also positive. So we are getting a positive voltage. We are getting a positive voltage. So changes in the variation in the voltage is positive, and the basically the signal that is coming from again loop, that is also positive. So there is no negative feedback. Okay, there is no negative feedback. So just on the basis of diagram, we can identify that which particularly terminal is. Now if I am using one circuit, V1, okay, 5K, 40K, 20K, 4K. First is identify The positive and negative terminal. In place of positive and negative, I am using the inverting and non-inverting. Identify the inverting and non-inverting terminal. Of op-amp. Okay, and second, find out V out. So can you solve it? Try to solve it once. Yeah. Yes, have you tried it? Now, which terminal is the inverting, which terminal is not inverting? Yes, please.
Sir, your screen is not visible, I think.
My screen is not visible.
Yeah, it's visible, sir.
Visible or not?
Yeah, it is visible.
Yeah, I think it's with my internet connection.
Okay.
Visible, sir.
I will share it again.
Okay, so I think it's an issue with my internet connection.
Okay. Yes, so which terminal is positive, which terminal is negative, first of all?
Bottom terminal should be inverting.
This particularly.
No, the bottom one.
With the inverting. And upper one is the non-inverting. Okay. So assume that the voltage at this point is the V1. The voltage at this point is the V2. So the value of V1 is, if I break the loop, change the voltage del V. So the V1 is del V into 5K upon addition of these two voltages, that is the 45K. So del V by 9. Okay. Now similarly, if we consider the V2, so V2 is del V into 4K upon 24K. Okay, so this is the del V by 6. Okay, so this voltage is greater than del V by 9. Okay, so that's why this terminal become negative, this terminal become positive. Now calculate the voltage, output voltage. Let's assume the VI is 5 volt. Yes, how we solve that one? Yes.
V1 is equal to 8 VI by 9 plus V out by 9. And V2
V1. Okay. So what is the value of V out?
V out will be 0.88 divided by 0.05 into VI.
Okay. Any other?
5.58 volts.
5.58 volt. Okay. So basically, first thing is that we identify the terminals. Now we know that this is the my negative terminal. So that particular negative terminal. So this particular negative feedback will be used for the feedbacking purpose. Okay. So if we are getting a V out voltage here. Okay. So what is the value of V out? V2. Okay. So like I just say that in place of V1 and V2, I just put it as a V positive and V negative. So now this we have as a Vx, V positive and V negative. Okay. So the value of V negative is V out voltage that is pass from this particularly branch. Okay, that is pass from this particularly branch. So some voltage will be drop across 4K and some voltage will be drop across the 20K. I want to identify the voltage drop across 4K. So the V out multiply with 4K divided by the 20 plus 4K. So that is V out into 4 by 24. We say that V out by 6. Okay. So the V negative is nothing but the V out by 6. If this particular terminal is V out by 6, that means this point is also same voltage. If this point is also same voltage, this one, so this point is also same voltage. So V minus is equal to the V plus. Why? Because negative feedback. In negative feedback, we apply the virtual ground concept. In this, the voltage V positive is equal to V negative. Okay, so both terminals will be having the same voltage. Now, if both terminals will be having the same voltage, so what is the current that is flowing from this particularly branch? This is Vi, this is Vi, and this voltage we know, the resistance we know, so the current that is flowing from the 5K. So that is nothing but Vi minus V plus upon 5K. That is the current. I just say that the I positive. The current is I positive. Okay, so the what is the value of I positive? Vi we know Vi is 5 minus V positive is V out by 6 upon 5K. So 30 minus V out upon 30K, that is a I positive current. Okay. Now, if this is the current, so the current will be passing from the outside circuit. Current will be passing from the outside circuit. So the current that is coming from this branch, it will be going to this branch. What is the value of current? The value of current is V positive minus V out upon 40K. That is also equal to the I plus current. That is also equal to the I plus current. So V positive value V out by 6 minus V out upon 40K, that is equal to 30 minus V out upon 30K. So this is a 3 by 4. Okay. If I take the, so it is V out by 6 minus V out, that is minus 5 V out by 6. 6 and 4, 24K is equal to 30 minus V out upon 3K. Now again it will be cancel out, it will be 8. Okay, so minus 5 V out is equal to 240 minus 8 V out. If I take it to this one, so it will be a 3 of V out is 240. That means V out is 80. My answer is this one, 80. We do any mistake? Please check.
Yes, sir. I'm also getting 80.
Okay. Anyone who is getting the 5.88, please verify.
Sir,
Yeah.
I actually quickly verified using V1 minus V2 equal to 0, but that time getting it as 88 volts. So is that wrong? I mean, is that
V1 minus V2 is equal to 0. You are using the virtual ground concept, okay?
Yes, sir.
So
So if I do it like that, it's maybe I'm doing a mistake. I don't know. It's
why you
almost
are taking the V1 minus V2? You are taking only this particular voltage, this point and this point.
yeah. V positive and V negative. I thought that should be 0, right? The
Yeah, due to the virtual ground concept, it is 0. Or we can say that V1 V minus is equal to V positive.
okay, sir.
You are getting a V minus. You just distribute del V
Yeah, I distributed, but then
minus
maybe yeah.
del V by 6 becomes 0. So it is a mm,
I'll do that later, sir. Because
how you measure the del V? Maybe you
um,
are okay. You just show me your screen what you are doing. You just send me basically the okay.
okay, sir. Yeah,
So that is better.
yeah.
Okay, so the thing is that we identify first of all this type circuit if two terminals will be getting the feedback. So first of all we identify where we having the larger voltage. Okay, so that particular terminal will be used as a negative, and where we have getting the smaller voltage we use that particular terminal as a positive. Now after that, with the respect to the positive terminal, we can calculate the output voltage. Okay, any doubts? Yes, any doubts?
No, sir.
Now what is the output voltage? So simply from this one we can say that this voltage is lesser, this voltage is higher. We already solved this one, so I am using this terminal. Now what is the output voltage? So first of all, we calculate the voltage at this point. Okay, with respect to the output voltage. So the output voltage will be dropped across this one and these two resistance. So apply the voltage divider. So this V negative voltage becomes 2 by 3 of V out. Okay. So this voltage also same voltage. So this voltage V positive is also same. So V negative and V positive both are same. Okay. Now this is the current I. So I just consider the I plus. So I plus is equal to the V I minus V positive upon R. So V positive is Vi minus 2 by 3 V out is equal to the R. Okay. And the same current that is flowing from this one also. So the current, I just say that I X. So Ix that is equal to I plus is equal to Ix is equal to Vx minus V out by 10R, and that is also equal to the I plus. Sorry, V positive. V positive minus V out by 10R. So V positive is this one. So 2 by 3 V out minus V out by 10R is equal to Vi minus 2 by 3 V out upon R. This R and R cancel out. It is minus 1 by 3 V out is equal to 10 times Vi minus 2 by 20 by 3 V out. If I take into this side, so it is a 19 by 3 V out is equal to 10 Vi, and V out upon Vi is equal to 30 by 90. The professor solved this question. Okay. So any doubt with this circuit? You can solve this type of circuit also.
Yes, sir.
Okay. Now if this is the V1, V2. Now what we do?
Superposition.
Apply the superposition theorem. Okay, apply the superposition theorem. One with respect to the V1, second with respect to the V2. Both current will be added. Okay, so I just say that like this one is the I1 plus and I2 plus. Okay, so both current will be added here and it will be go in this direction. Okay, so I1 plus is what? I1 plus is V1 minus V plus by R, and I2 plus is V2 minus V plus upon R. Total I current I plus is I1 plus I2 plus. Okay, so this is the I1 I plus, and that all current will be going in this way. So that I plus is equal to Ix. Okay, so we can solve this type of question also. Now, if you have any doubt, you can ask.
Sir, the GA questions, did you check, sir?
GA question I will check after 26.
Okay.
If you have any particular doubt, I will just give you the hint, but I will check after 26. Okay.
Okay, sir.
So, can you try this question? What is the output voltage? Yes, what is the output?
I got 4.74 volts.
V out is 4.74 volt.
Yes, sir. 4.7368.
Yeah. Any other? So what is the voltage at this particular terminal is? V out into 10 by 30. Okay, so V out by 3. That is the voltage at V positive or V negative. Okay. Now the current, I am just saying that this is the I1 current, this is the I2 current. So I1 current is equal to V1 minus V plus upon 2, that is 1 minus V out by 3 upon 2k, and I2 is equal to 2 minus V out by 3 upon 2k. So this is the 3 minus V out upon 6K, and this is 6 minus V out upon 6K. Okay, now these two current will be added. So if I add these two current, so 9 minus 2 times of V out upon 6K, that current will be passing from this branch. So it is V plus minus V out upon 40K. Okay, and V 9 minus 2 V out upon 6K is equal to V out by 3 minus V out upon 40K. So K and K will be cancelled out. If I multiply 3 and 20, so 9 minus 2 V out is equal to minus 2 V out by 20 into 3, and 3 will be cancelled out with 3. So 180 minus 40 V out is equal to minus 2 V out. So 180 is equal to 38 V out, and V out is equal to 180 upon 38. So it is around 4.74 volt. Okay. Any doubt in this?
No, sir.
Okay. So in this way, we solve this type of question. So I think that's it for week 2. In the next class, that is I think on Tuesday, yeah, we will discuss the practice assignment second and the solution of graded assignment. If we have any doubt in the graded assignment, we will solve that one in the Tuesday class. So thank you all.
Thank you, sir.
Yeah.